Good day to all. Today we are going to see about that pneumatic actuators and some other types. See, in that actuators, there are a lot of type of actuators. As we know already, in that hydraulic system, we saw about what is that actuator. Actuator is nothing but a mover. It is used to move the piston from one place to other place. Here also the same process will occur, but the thing is here it the application its work behind that air, whereas in that hydraulic it is used with the help of oil. These are the types. First one is plunger and push button, lever, roller, pilot air and roller trip, solenoid, diaphragm, foot pedal and spring. Then we'll move about that the T-piece. See this T-piece, here you can see it is called T-piece or T connector. The thing is we can get air from two sides. The input of the air is one side and the output you can see here the air of out will come. Here also the air out will come. It is a connector. It's simple in component that lets as split or divided the airflow. It can be very useful. Why? Because if we want to add two cylinder to operate at the same time, we can use, see here, the air is going and the pressurized air is going here, and we will have some air output here as well as some we have here. If we want to move some piston over here, if you want to move piston some over here, this one is a cylinder 1 or piston 1, this one is a cylinder 2 or piston 2, we can use both of that cylinder at the same time. This is the main purpose of this T-piece. Then and control. See, as we know already, what is that and control? If the both input is high, we will get the output. That is the AND gate. As you know already, if it's the input is low, 0, 0, the output is 0, 0, 1, the output is 0, 1, 0, the output is 0, 1, 1 only, the output will is 1. If the both input is 0, the output will be 0. If any one of the input is also high, means the output is low. If the both input is high, only the output will high. That is the uncontrol. Why we are using this uncontrol here means, see already as we know, pneumatic circuits are very safe, but it is important to take safety precautions. So uncontrolled circuits can be used to help the prevent accidents by ensuring the guards are in a position before machines are switched on. These circuits can also be used to stop a machine being switched on accidentally. If it is the machine switched on accidentally, we can easily stop that machine with the help of this hand control. As well as to stop the operators placing their hands. If suppose anybody they are placing their hands in that machine, easily we can stop the machine with the help of this hand control. So this is the uncontrolled. Then one R control. See R control. Sometimes we need to control a pneumatic circuit from more than one position. This can be done using R control circuits. These circuits are quite simple, but they need another component called shuttle valve. This shuttle valve is used to change the direction of an air in a circuit. It has a small ball inside that gets blown from side to side. You can see this picture. This is a ball. This is wall A. This is wall B, and this will go into cylinder, and the air will come here as well as here. The output air will also go here. This is the ball. It is called that shuttle valve. And this shuttle valve, see, when air is supplied from a valve, the valve gets blown across, and air is directed towards the cylinder. When air is supplied from valve B, see, before diagram we see about that valve A is here, valve A is here, and valve B is here. Okay, this is the ball, and air will come from this side as well as this side. Pressurized air will come from this A side also as well as this B side also. So, when the air is supplied from a valve B, the ball is blown to the other side. If the air is coming here, then this ball will blown to other side. And again, the air flows into the cylinder. If the air comes the both direction, what will happen? See, if the air is coming from valve B, then this ball will blown here and the air move up here. If the air come pressurized air coming from this valve A, then this ball will blown here. Then the air will move up from this way. If suppose if air comes both direction, if you think that the air comes from valve A also, at the same time the air is coming from valve B also, what will happen? Where the ball will go? That is the main advantage of this shuttle valve. If the air comes both direction, the air still manage to reach the cylinder, as this is the only path it can take. So it will manage. But in other valve, we cannot take like this. See, for example, if it is T valve, as we seen here before, T valve we can get both direction here. So you can see the both direction at the same time. But the thing is, here the input is single, the output is 2. Whereas in the shuttle valve, output is single, the input is 2. Because we can operate here with 2 cylinder with 1 input. But you see here in that shuttle valve, here we have a 1 output. Here only 1 output here. The cylinder will move up. If the valve is coming here, for example, if the cylinder is here, the piston will here. If the valve is coming here, means this cylinder will move up to here. Okay. Likewise, if the air is coming from here, means this cylinder again it will return back to the particular original position like this. But if the same time air will coming from this side also, more pressure will come, that time it will manage. That is the thing here. It denotes if air comes both direction, the air still manages to reach the cylinder. This is the main concept of shuttle valve. Thank you.